Welcome back for another VMK in the OpenGL Tips and Tricks series. In this VMK, I'm going to try to wrap things up with the sprites now. I've showed you how to create a sprite class, how to control it using arrow keys, and now let's go take a look at how we can animate sprites. Sprite animation is very easy to do, and it's not that difficult to understand either. So let's take a look in here inside of Photoshop how we're going to achieve sprite animation. Let's say we have a police car, like this one up here, that we want to animate. And what we want to animate on him is, let's just animate the light so that his lights flash whenever you press the space bar. The way you would animate something like this is you would create a sprite in its standard state, like it is right now, and then you'd have to create another image of it when it's flashing its lights. So that's what I've gone ahead and done. I have my regular cop car here. I created a duplicate copy of that police car over here, and I also lit up the lights so that it looks like the lights are on. Now when we go and render this police car on the screen, I'm going to create a sprite that's roughly the size of the car itself. If I turn the grid on, you can sort of see here how big it is. The sprite for the police car is going to be this rectangle here, and I'm going to say, please render this image over here. Then when I want to render with the lights on, all I'm going to say is render this image over here rather than this one over here. So what's going to happen is visually you're going to see no lights on, and then all of a sudden the lights will turn on. And by changing how often you render this one as opposed to this one, you can change the frequency at which the lights flash. So let's go into our code and implement this simple strategy. Make sure that you take the TGA file that comes with this VMK and you place it under the resources texture folder into here. So there's animate.tga. That's the texture file that has the image of the police car with its lights off and with the lights on. Alright, so here's our code. We need to go into our scene class. Inside of our initialize, we need to load that new TGA file. I called it animate. We'll load that into, oh no, that's not where I wanted to load it. We don't need this guy anymore. We want to use this GUI texture ID value, and here we're going to be loading our animate.tga file. Inside of this GUI render function, here's where, I didn't find it. Here's where we do the rendering of everything to the screen. Let's just comment everything out initially so that we can see that we're starting with a blank slate. So I'll just delete it. We still want to set up the model view matrix to be identity. We're going to enable textures. We're going to bind to that texture which we just loaded our image into. And let's comment this out here. We're going to do some work here. And then after we're done all that, we can disable our texture which we enabled up above. So let's just run this and take a look to see what we have on our screen. Okay, so right now we're just rendering a black screen. What I want to do is I want to change the background color from black to be this gray color, just so that things blend in nicely. When I created the TGA file, which is included with this VMK, I didn't associate an alpha channel, so the gray background will be rendering. However, when you do this for your projects, you should use an alpha channel so that the background doesn't appear. Found inside of the game OpenGL show menu function call, we're setting the background color to be black here. We can see, let's just change this to be this sort of grayish color that's inside of the TGA file. Now when we run this, we should see a gray background. Okay? Alright, now let's go and render our police car. Back inside a GUI render, we need to set up a couple variables. One variable to indicate where on the screen we want to render our car, and another variable to represent how large is our texture so that we know what are the bounds of the entire image that we're interested in. And as you saw already inside of here, we're only interested in the top left-hand corner here since that's where the car is located. We don't want to be rendering everything. We only want to be rendering that sort of rectangular region up here. This code should look very familiar to you since we've been using it quite extensively recently. Here's our first variable for v2 position. This is going to locate our car on the screen, so I'm placing it roughly 600 pixels across, 400 pixels up. It's just a little bit off to the right. The size of our car is 168 pixels by 79 pixels tall. That means, if I turn the grid back on here, this is how wide and how tall this rectangle here is. Also, I need to specify the bottom left-hand corner of the rectangle that I want to be rendering to the screen. These numbers here are in pixels, and I'm going to be converting them to be in texture coordinate space, which is a value between 0 and 1. So because our image, our texture image, is 1024 wide, I need to divide by 1023 here to convert these values here to be in texture coordinate space. So here's our rendering code. I select the texture coordinate. I say, here's the x coordinate that I want to use, converted to be in texture space by this factor. And then here's our y coordinate converted over using the factor as well. Then we have our vertex coordinate, so our x in the y position, and z is always 0. Then I go and render the next corner, and the next corner. So I'm rendering one quad here. Let's go try this out, and we should be able to see our police car on the screen with the lights turned off. And that's what we see over here. Now, what I want to do is animate this guy, and the way that I'm going to start off is just by saying, if I press the space bar, I want to turn the lights on. Let's go take a look at how that's going to work. All I need to do is check to see if the space bar is being pressed using the P user settings B keys. If it is being pressed, I'm going to change it to be not pressed here, and then I'm going to say that the texture coordinate for the x value here, I'm going to change from 0 to 169 pixels. Remember, the width of my box here is 168 pixels wide. So that means that the box on the left side here goes from pixel number 1 all the way to pixel 168. So the next one over is 169. So I can pick off that bottom left-hand corner just by changing the x coordinate over here. Oh, I forgot to mention the size here is actually the size of my rectangle minus 1. That's very important because remember there's that 1 pixel offset that kept creeping up inside of the game engine. Well, I've already subtracted the 1 pixel from each of these. So if we go into our image here and measure how large this rectangle is, we'll see that it's not 168 by 79, it's actually 169 by 80. So I've subtracted 1 pixel in each of these dimensions already. That means that the left-hand car that you see inside of the texture image will go from pixel coordinate 0 to pixel coordinate 168. The car to the right, this car over here, means this coordinate is 169 and it goes all the way to 169 plus 168. So that's where I get those coordinates from. If I press the space bar, all I want to do is offset the 0 value to be located at 169. Let's go try this out. So we can see here, here's the police car, its lights are off. If I press the space bar, then the lights flash on. I actually have to press and hold the space bar to maintain the lights being off, since every time I render the frame, I default back down to a texture coordinate of 0 here. Let's go change our code slightly so that the behavior is a little bit more user-friendly. I'll create a static member variable here, which is just a boolean, and I'll call it beOn. Initially, I'm going to set this guy to be false. Anytime we press the space bar, what I'm going to do is I'm going to toggle the beOn value. True, it's going to turn false, and if it's false, it's going to turn true. Now, down below here, I'm going to say if B is on, then I want to move the texture coordinate over. Otherwise, I'm going to use it at the default value of 0. Now let's go try this out. This should be, correct this here. This should be beOn is equal to the not value of the variable beOn. Alright, so the police car lights are off. If I press the space bar once, you notice that the lights turn on and they stay on. If I press it again, now they turn off. And so if I just continually toggle the space bar, I can toggle lights on and off. And it's very important that when you set up your sprites inside of whatever texture editing software you have, I'm using Photoshop for this example, you position all of the images perfectly aligned. So in other words, the car here cannot be vertically offset at all, because as soon as you do that, when you're toggling from the image on the left to the image on the right, you'll notice this car moving slightly up and down, so it's going to look like it's bumping. The location of the car with respect to the frame that it's sitting in has to be precise. If you do that correctly, then you'll see you get a very realistic animation, or in this case, flashing of the lights, because all that's happening is you're changing the pixels around where the lights are to be different color than what they were previously. So to the human eye, it looks like the lights are turning on, when in reality it's just like a flipbook effect. You're rendering this image or you're rendering that one over here. We can take this a little bit further, and instead of having the lights turn on or off based on the space bar, I'm going to modify this code some more so that now when we press the space bar, we'll start flashing the lights, and then when we press the space bar again, then the lights will stop flashing. And here's the code that will do that. Because the flashing is going to be time dependent, we need to be able to get the current time of the game, which we have stored inside of the game OpenGL class. And I'm using our fmod operator again, because this guy is very helpful when trying to perform these kinds of actions. So let's take a look at what's happening here. Initially, BON is going to be false, meaning the lights are off. When we press the space bar, we're going to toggle that variable to be true, so that indicates that the lights are now turned on. When the variable is true, we're going to go into this if statement. Anytime we're inside of this if statement, we calculate ft, which is a value that's going to range between 0 and 0.5. Remember, the fmod operator will return to us a variable that ranges between 0 and whatever value is here in the second parameter. Then what I'm going to do is I'm going to check to see what is the value of ft. If it's less than 0.25, then I'm going to move my texture coordinate across to the second frame. If it's more than 0.25, then I'm going to leave it at the default, which is 0. So based on this time value here, we're going to be flashing our lights. Let's go try this out. Okay, we see that the lights are off. If I press the spacebar once, notice that the lights begin to flash. I don't know how this is going to render inside of the video once I encode everything, because I'm capturing at 10 frames per second. But on the screen, you should see sort of a constant flashing rate of the lights on the car. If I press the spacebar again, then we turn the lights off. You can change the frequency at which the lights flash on and off just by changing this variable here. Right now, I'm saying every quarter of a second, we're going to be toggling between on and off and on, and so on. So if I wanted to increase the rate at which the lights flash, maybe make this 0.2, and then we'll change this variable to be 0.1, then we're going to get a faster flash rate. So notice now that the lights are flashing much, much faster. Okay, so that's a very simple way to create animations inside of your games using sprites. Now let's take a look at a little bit more complex way of doing a very similar kind of thing. What I did is I went into some 3D modeling software, created a figure, and then I animated him so that he's running across the screen. The results are shown inside of this image here. So we start off with one frame where this guy is sort of in mid-stride here. The next frame he's moved over a little bit more, a little bit more, a little bit more, and so on. So you can see as he's running, he's moving across the screen, and all it is just a bunch of 2D images that I've captured showing this guy running across the screen. Now what I want to do is I want to take each of these images and cut them out and paste them into a separate file. The separate file is going to be a fixed size, like so, and I've positioned the guy so that he's centered on the screen. But it's very important how I position him. Remember when I was saying that when I position these police cars, I need to make sure that the police car location with respect to the box that surrounds it is exact. In other words, the location of the door is an exact same pixel that it is located over here inside of this frame on this side. Well, the same thing goes when I'm working with this animated character. But the reference point that I'm using is his hip. So if I turn the grid on, you notice that I created a vertical line right down the center, and I've tried to maintain the guy's hip right at the very center of this line here. you can see he moves vertically as he's running because he sort of has to lift himself off the ground before he can place the next step. But I've tried to maintain sort of the location of his hip constant with respect to the shape of this image. So all I've done is I've taken all of these images here and I've cut them out and I've placed them so that they're all centered about this point. Now that I have this, I can then go back into my TGA file where I'm going to be importing into the game engine, and I created another grid. This grid, you can see here, it's a 5 wide by 3 tall. Don't worry about this extra stuff at the top here. And I've placed each of those individual images that I've created into one of those frames. So now when I want to render this is going to work exactly like a flipbook does. I'm going to render one frame, then the next time that I go and render, I want to render the next one, and then the next one, the next one, the next one. So all I need to do now is figure out what is the bottom left-hand coordinate of each of these frames so that when I want to render the appropriate one, I know which part I need to grab. And the size of each of these grids are fixed, just like they were in this case here. The size of this rectangle is the same size as this rectangle here. So positioning of my character inside of this grid is very critical to making the animation look realistic. Now that we have this TGA file, let's go and load it into our game engine and see if we can get the guy to animate on the screen. I'm going to need the position, I'm going to need the size, and I'm going to need the texture coordinates. This stuff here I'm going to delete. Let's start off our image somewhere, I don't know, let's say 300 pixels to the right and 10 pixels off the ground. The size of each individual grid that the guy's image is inside of is no longer 168 by 79, it's now 168 by 210. It's actually 211, but I subtract ones, that's why I have 210 here. Now we need to figure out which texture coordinates to use to render the guy to the screen. Previously we were saying render the image on the left, which was coordinate 0, 0, or if we press the space bar, then we want to render the image on the right. But now we want the computer to decide which of the 15 different images to choose from, because we got 15 here to choose from. It really depends on the timing to decide which one to render next. So we're going to be using the GameOpenGL class to tell us what time it is, and then based on the time, we can then calculate which of the appropriate images to use. We're just going to declare our texture variable here at the top. He's going to be blank initially, and then based on the following calculation, it's going to pick off the appropriate texture coordinate that we want to use. I've sort of written all this stuff out by hand so that it's easy to understand how I get these values. However, you can simplify these by applying formulas to actually derive each of these coordinates. So let's take a look at what I did. I created a variable here called fspeed, and I've set it to be 0.1. The fspeed value is going to dictate how quickly we want to transition from one frame to the next. We then use the fmod operator again to calculate our variable ft. We'll need to declare him here. Using the fmod operator, I get the current time, and then I take the speed value, which is declared up here, and I multiply it by 15. 15 is how many individual frames I have of the running guy. We have 5 across and 3 up, so that's 15. Then, because we have 15 images, there's 15 choices here using all these different if-else statements to decide which is the bottom left-hand coordinate to use. If ft is less than or equal to the speed factor here, then we want to use a 0, 0. 0, 0 happens to be this point right here for the first image. If the value is less than or equal to fspeed times 2, then I want to use the next one over. So that means this image here. So I move across 169 pixels and the y-coordinate is still 0. If the f-speed factor is 3 times, then I move over 168 times 2 and y is 0. If it's 4, then I move 3 times across. If it's 5, then I move 4 times across. If it's 6, then I'm in the second row. So the first coordinate is back down to 0, and this time I've moved up by 211 pixels. If it's 7, I move across, so across 169, and the y-coordinate remains the same, and all the way across. And then when I move to the third row, we can see it over here. We have 0 for the x, and then 2 times 211 to move up to the third row. So this just picks off the appropriate texture coordinate for each image inside of that matrix. Then finally the rendering code is exactly the same. Let's go and try this out and see what happens. Oh, my declaration here should be 0, 0. Let's try that. Okay, so when we fire this up, we notice that we have our running guy. He's probably getting cut off at the bottom of the screen, so let's move him up a little bit more. Let's maybe move him to 50. Okay, so you should be able to see the running guy now running at the very bottom of the screen. He's stationary with respect to the window, but he appears to be running on the spot. Now we can play around with these variables. The speed factor here dictates how quickly we transition from one frame to the next. So if we increase the speed factor to 0.2, well, let's make it obvious. Let's make it 0.4, let's say. So now the speed factor is 4 times what it was before. And if we take a look, you'll notice that he's actually running 4 times slower. So the speed factor represents how long we wait before we transition from one frame to the next. If we want him to run faster, then we just change this value to be smaller. So instead of 0.1, we'll make it 0.05, let's say. Now 0.05 is half of 0.1, so he should be running twice as fast as what he originally was running. So there we go. You can see him. He's now at a pretty quick jog. Alright, so that's what that speed factor does. I'm going to change it back to 0.1 to play with. The other thing we want to do is we don't want him to be running on the spot. We want him to be running across the screen. So we need another factor to dictate where to position him on the screen. We already have this variable here to indicate we want to draw him located at 300 pixels across, 500 pixels up, but we want to change this factor so that he's actually moving across the screen, which means we want to be changing this x-coordinate appropriately. Here's some code that will do that trick. I'll need to create a new variable called fRunSpeed. It'll be a floating point number, and he's going to be static as well. fRunSpeed. And this variable is going to indicate how many pixels per second we're going to be moving the image of the guy across the screen. Initially, I'm going to set it up to be 100 pixels per second because I don't know what a good number is. We're then going to go and tweak this value to correct it so that things look realistic. Again, I'm using the fmod operator, so I'm getting the current time of the game, and I'm multiplying it by the speed. Remember, speed times time will give you distance, so this gives me a distance that I've traveled across the screen. I want to cap the distance to be between 0 and 1200 pixels. The size of my screen is 1024, but I need to give myself a couple extra pixels buffer size because the bottom left-hand coordinate is what I'm using to render the guy on the screen. So when the bottom left-hand coordinate is close to the edge of the screen, I still want to render him because most of him is going to be off the screen, but you may want to still see like his foot or something. So I need to give myself a little bit more room to continually render things while he's running across the screen. So that's why I've chosen here 1200. Now, I don't want to start at 0 because 0 would mean that the guy, when he gets rendered on the screen, he would appear here on the left side and then start running across, run off the screen, and then reappear. Well, actually, let me do that and you can see what's going on, and then you'll understand why I need to add that extra factor on the end there. So basically all I've done is I've said, here's my speed factor at which I'm going to be moving the guy across on the screen, and then this calculates what is my new x-coordinate for the position of the guy on the screen. Let's go give this a try. Notice now that the guy is running across the screen, but the speed at which he looks like he's jogging doesn't really match up with how quickly he's moving across the screen. He moves off the screen, he's gone for a little bit, and then he reappears immediately over here, and then he runs off again. So instead of having him reappear right here, I want him to actually run onto the screen as well, just the same as he's running off the screen right now. So to do that, I just want to changed this variable here to be minus 170 pixels, which means start him not at 0, but start him at minus 170, and then run him onto the screen, across the screen, and then run him also off the screen as well. So now when we fire this up, you'll see that there's a better transition of him coming on and off the screen. Notice he runs onto the screen, and as he's coming off, he runs smoothly off, and then you can see him running back onto the screen. Okay, so we have him running across the screen now smoothly, but our running rate doesn't match up with how quickly we're moving him across the screen. We can tune it by hand, or we can figure out what should the running speed be to make things look correct. Let's first tune it by hand. I'm going to use the arrow keys on the keyboard to change the running speed value by 5 every time we press the key. So when I'm pressing the up arrow key, we're going to be incrementing by 5. If I press the down arrow key, I'm going to reduce the value by 5. And if we go less than or equal to 0, then I'm going to just change the running speed equal to 1. So we can't go beyond 0, because a zero running speed wouldn't make much sense. We do want him to move on the screen. Let's try this out. We've seen already how quickly he's running across the screen. So I'm going to press the up arrow key, and you can see he sort of slides across, and now he's running faster. If I continually hold it, and when I let go, then we can analyze to see whether he's running at the correct rate. If I crank it up way too much, like something like this, you notice that he's sliding across on the floor as he's running across. So he's obviously moving too quickly with respect to how quickly he appears to be running. If I decrease the speed down to the minimum value, then he almost looks like he's running on the spot. He's barely moving at all. Notice that he's not transitioning forward very much, even though he looks like he's doing a lot of jogging. And here's the extreme. He's running a lot, but he's really not moving at all. So there's a sweet factor somewhere that will be the correct number. You can sort of eyeball it. That doesn't look too bad. I mean, he looks like he's running at roughly the correct rate. And if we go into Visual Studio and take a look at what that value is right now, we can see that the current value is set to be about 286. So 286 appears to be close to what the correct value is. Now let's go and start our program and actually figure out mathematically what is the right value. We need to go back into Photoshop and take a look at our images here. Actually, we'll go back to this one here. This one here had our images showing the guy transitioning across the screen appropriately based on the animation curves that were done inside of my 3D modeling program. So he is moving across the screen at the correct rate. What I can do here is create a grid and analyze where his hip is as we're transitioning across the screen. And as I do this, let's go down to here, so we can see his hip is here, then on the next frame his hip is over here, on the next frame his hip is over here, and so on. So as I do this, I can see that he has a relative constant distance between each frame. So one frame to the next frame to the next frame, he moves approximately this far on the screen. Knowing that, I can measure what is the distance between this and this, and it happens to work out to be 27 pixels. So every single frame that he's running, he's moving 27 pixels forward in his running cycle. Now going back into our code, we saw that we set up this speed factor here. The speed factor represents how many seconds it takes to transition from one frame to the next. So when we will render one frame, then we'll wait this amount of seconds before we render the next frame. Well, we know that we're transitioning 27 pixels per frame, and each frame is rendered at 0.1 seconds. So if we do the division here, 27 divided by 0.1, we get 270. 270 is the running speed that will make the character look like he's running at the correct rate. So in other words, he should be moving 270 pixels per second according to this variable here and according to the images that we generated. So let's go and run the program one last time now using the running speed of 270 and take a look at how that relates. So there we go. You can see him running across the screen, and sure enough, 270 makes him look like he's running across the screen correctly. That's all I wanted to show in this VMK. It's a quick crash course on animating sprites. If you do a search on Google for game sprites, you'll be able to find very many images that look very similar to what I created over here for the running guy. There's this one website which I quickly found under panelmonkey.org, and for instance, here are all the sprites of Link from a famous Nintendo 64 game. You notice that the artist created Link in many different poses, and while you're playing the game, all that's happening is you're saying render one frame, transition to the next one, transition to the next one, and so on. So when this happens on the screen, it actually looks like Link is moving, swinging swords, jumping, running. I think over here he's spitting. But that's basically how it works. So when you're creating your own games and you're creating sprites for them, all you have to do is create your images for your different characters that you have in your game, move them from one pose to the next, capture the images, store them into one file, and then when you go and render, all you do is you pick off the appropriate frame of animation that you want to render and render that to the screen. If you find my videos helpful and you can support the website, you can do so by clicking on any of the Google ads found at the side or by purchasing something from the store.